So, today is about genetic engineering. And genetic engineering is this future fantastic part of science, because basically genetic engineering is about taking genes from one organism and inserting them into another to make them produce that protein. Alright? Because don't forget, genes code for proteins. Do you remember that? Alright, so here's our example that we've got. Okay? Let me go back a little bit. Have a little read. So, we're going back to that whole Austin Powers thing. Mini-me wants to be bigger. Alright? And he's going to use this fantastic thing called a bacteria. I've come across those before. The wonderful thing about science is we can make bacteria make stuff for us, and that's what's really clever. Anyway, in the chromosomes of a tall person, let's call it Mr. Big, there is a gene, and that's the pink bit in the diagram. There is a gene that causes him to be tall. And clearly, Mini-me's not got it. Otherwise he'd be tall. But we can actually take that gene out and, in theory, insert it into something else. And this is genetic engineering. Alright? So there, that pink bit there, is the gene that makes a person tall. And we've discovered this as human beings. It's very, very clever. And what we do is, we cut out the gene. This is the main step. We cut the gene out with an enzyme. Alright? So, what I'd like to have is a pair of scissors that represents the enzyme. It's not a pair of scissors, it's an enzyme, but that's how I try to represent it. And the enzyme cuts out that gene from a human. Let me come back to that one. I mean, he wants to do it to get taller, but I'm going to give you a real life example. Now, this was the bacteria we talked about. And bacteria have this very funny little bit in their structure called a plasmid. That yellow circle is DNA. Alright? The great thing about plasmids is we can manipulate them, we can change them around, we can insert stuff into them, we can take stuff out. So what we do as scientists is we remove the plasmid from the bacteria and then we cut open the plasmid, again using that keyword enzyme. What do you think we're going to do now?
Insert the tall.
Good lad. We're going to take that human tall gene and put it into this plasmid. So, that is what we do. We take that human small gene, tall gene, sorry, we insert it back into the plasmid, and the plasmid then is rejoined. We then put the plasmid back into the bacteria. Can you see there that the bacteria has now got that tall gene inside it? And the bacteria then read that gene and they're like, oh, supposedly I've got to make the protein that makes me tall. Or that makes humans tall. Where's that come from? Oh, well, it's in my instructions. It's in my DNA, so I better make it. And the bacteria then start to make the protein that makes a person tall. Now, that is pretty wonderful, because bacteria, we can make divide and replicate, and we can turn one bacteria into 10,000 bacteria in about a space of a day. And 'cause bacteria replicate asexually, do you remember we did that sexual, asexual? Every single new bacteria has that tall human gene. And so every single new bacteria will be making human growth protein. Do you get that?
Yeah.
And so what then we do is we put them into a flask, and actually, we don't, in real life, these are massive fermenters, about the size of 2 houses. And those fermenters are making human growth hormone. They're making a protein that allows us to grow. Now, Chloe, you said, well, what's the point of that in real life? And I'll tell you the story. There is a gene that makes insulin. Now, who knows what insulin's used for? There are diabetes? Yeah. If you're diabetic, you can't make insulin, right? We used to take the insulin from pigs, dead pigs, suck the insulin out and give it to people. And then somebody decided, Chloe, do you know what? I found the gene that makes insulin, like they found the gene that caused the growth protein. They found the gene for insulin in humans, cut it out, inserted the insulin gene into a bacteria. The bacteria then started to make the insulin, and all of a sudden, we could make human insulin that we could give to every single diabetic in the world so they could inject themselves.
I don't get why everybody tall then.
That was just an example, all right? And it's not quite as simple as that, but we could, in essence, in science, if science carries on as it is, we could make every single gene and we could be whatever we needed to be. But that's science fiction. You with me? So, that is the theory of genetic engineering.